Hey, Trin, is there more coming behind you? Welcome. We're going to continue notes, so just have your notes out in front of you. Once we're done with the notes, we're done for today. So very, very easy. No homework today. I know it's a short period, so. Okay, let's do a quick recap of what we did yesterday. Okay, so just real quick here, talking about section 1.7. Difficulties this morning already. Why is the mouse in there? The mouse is honestly not sitting there. Where's my mouse? Why is it sitting there? This is a cruel joke. Seriously. I can't anything doesn't work right. It's still there! Technology hates me right now. Maybe it didn't like me putting a cable to the ceiling. Hey, it's gone. Please, God, don't stay on back there. Yeah, alright, so three-dimensional object. Alright, so here's the idea. The outline we started yesterday, right? We talked about polyhedra. So the big thing with yesterday was the face, the edges, and vertices. Do we feel comfortable with those words from yesterday? Remember, the faces are like the actual sides of the object. I call them facets of it, right? The planes. Then you have the edges where the actual lines connecting them, right? And then you have vertices, which are the corners. Now, there was one other word we threw in there. What was the other word we threw in with these? Start with a B. Base. Base is the part of the system, right? All right, so then we talked about prisms. We introed like some of the names for prisms. We'll go back to that here just in a second, just to make sure that you're comfortable with that. And then we finished with pyramids, but the goal today is to pick up where we left off. To pick up right at pyramids and to talk about, because I did want to show you those pictures. Like yesterday, I was hinting at the fact, like the pyramid of Giza and stuff. Today, I want to pick up right where that left off. Okay, because I think we just discussed out loud, correct? We didn't really see any pictures on that? Okay, perfect. All right. Okay, so we talked about those two, and then we talked about, I think we introed cylinder, cones, and spheres, correct? Like those actual objects. Then just one of those days. All right, regular polyhedra, and then when we talked about the regular polyhedra, these are the ones where all the facets of the faces were exactly the exact same shape. So it was like a triangle, and they were all triangles, every single one. There wasn't a mix of like rectangles and triangles. They were all triangles in that object. But the big thing is that all those triangles were regular. They were regular, polygons. So they could have been a triangle, they could have been a square, they could have been a pentagon. But then when you put them together, they make a certain shape. So we intro like the first five. We call those platonic solids. That's what you need to realize. That's the big fancy term that we use for that, when they're exactly like all regular. Okay? And I think the idea that I talked about with these, we talked about like dice. When you play like a dice game, like Dungeons and Dragons and stuff. Then to goal today is to talk about surface area, so that you know what that is, you know how to calculate it. And then volume. Now the ideas with these two, I'll give you the formulas for kind of the weirder shapes, like pyramids and spheres, because those volume formulas are actually very, very different. Okay, so I'll at least give you a picture of them. They're in your textbook, at least, but you'll at least have them. Because some people never get to see those. Like you'd have to like look it up online to see it, because volume mostly, like in high school, is limited to: do you know how to find the volume of a cube? Do you know how to find the volume of a triangular prism? Like that's all they limit you to. I mean, but there's spheres and there's other objects. So I do want to give you those formulas so that you have them in case you have them like in the ACT, a maps testing that. Okay, so that's our idea, but I want to start with kind of the pyramid, but let's cruise through these first couple so we can get to the pyramid idea, because that's where I want to finish today. All right, so the polyhedra, we talked about, singular. They had faces and edges. So this is a new part here. I threw this in here so that you understand like what I'm talking about with faces and edges and vertex. Okay, face is the flat surface, edges are the segments, and then we talked about the base. And bases can be anything. It's just the plate that it sits on. And objects can have multiple bases if the object is the exact same base. So like top and bottom, they're like parallel in the same shape. We could have two bases like this object. And this is a type of prism. So we'll get to that eventually. But typically, like in a pyramid, there's only one base, the part that it sits on. Like up here, technically, you do have two bases, but they're different in shape. So we'd only put like the bottom one base. That's the idea. Okay. Regular, they had to have the same faces that were regular in terms of polygons, right? And then they're equal. That's what needs to be regular. And I'll put that back up here. All right, so regular polyhedra, the faces are regular. So the five types again were tetrahedron. That was the triangle. I call it the triangular pyramid. The base is a triangle. You can see it. That is a triangle for a base, not a square pyramid like most people think. And then we have the hexahedron, which is square faces. So it's a cube. That's the common term that people refer to that as, but it's actually called a hexahedron. There's 6 faces, if they're all squares. Okay. Octahedron, there was 8 triangles connected, and this one's pretty easy to see. It looks like 2 square pyramids stacked on top of each other. There is technically no base there, because the plate in the middle isn't actually there. And then dodecahedron, there's 12 pentagons here. That's pretty easy to see. That's actually called like a princess cut diamond kind of thing, as opposed to a square diamond. And then I think it's isosahedron or icosahedron. I can't remember what the pronunciation is. But that's 20 triangles connected. And I see that picture. I still can't wrap my head around the triangles right here in this area in white. I still can't see that, like where that is. But I understand there is 20 sides. I just can't see it in this picture. That's the same one I've seen since college. All right. any questions with the regular ones? Now, again, these are called Platonic section, or Platonic solids. That was that key term. I probably should put it up here. Maybe before I post this today, because I forgot to post yesterday because we had a volleyball game. I might put right here like Platonic solids, because that's actually the correct term. Okay? Alright, now, the other thing we talked about was, when we talk about polyhedra, there's two main categories. There's the prisms, which basically prisms have parallel walls, like there's the same polygons top and bottom. So that's the idea. So it has two parallel congruent faces. So that's where this picture could have different bases, and that was the picture I showed you earlier. That's a prism, right? The top and bottom are actually parallel, and they're the exact same picture. There's no difference. That's why it has multiple bases, not just one like that one picture I showed you way earlier. Okay. How you name prisms are by whatever the base is, the items that are parallel. So what is this top thing? Hang on. So that's a pentagonal prism. That's how we call it. Okay. And then we had pyramids, and there was a bunch of different types of pyramids. So remember, a pyramid has some type of polygon for a base, and then all the faces that go up meet at a singular point. So that's the idea, and that's called a vertex. Now on this particular picture, what is the bottom? The square rectangle, so you can call it a square pyramid or a rectangular pyramid. That's kind of the idea what you call that. There's 4 triangles going on. Okay. Now the other things that are not polyhedra. They're solids. They're like a 3-dimensional object, but they're definitely not a polyhedra. Polyhedras have flat edges, like flat walls. Things that have curves. So it'd be like the cylinder. Cylinder has 2 parallel circles, so those are your bases, circular bases, and then it has a curved surface that wraps around. This picture really mimics the top one. It looks like a prism. It's just, but it's using circles and curves. That's why it's the first category of non-polyhedra, which is cylinders. The next one is a cone. It kind of mimics the pyramid. You have some base, which in our case will be a circle, and then goes up to a singular point. So that's your cone. And then the last one we talked about was a sphere. Now, did we talk about yesterday that planet Earth is not a sphere? Okay. I'm not in that weird, like, crazy camp where people think that the Earth is flat. That's totally stupid, and I don't think that way. I understand that it's a sphere. I've seen pictures of it, right? But it's squished a little bit. The Earth is not perfectly spherical. Even when you look at the atmosphere, it's not spherical. It's like crunched a little bit north and south-wise, because the way that the Earth orbits the sun is actually pulling to the equator more. So it's elongating us like a football, basically. That's over like billions of years of doing that. So, but it's just, it mimics a sphere. If you were to look at it, it's just a hair imperfect. But again, it's all the points equidistant from a central point. So it's the set of all points. So that's why it wraps around that central point, the core. Okay, but these are non-polyhedra, and these are polyhedrons. So you can kind of see they kind of mimic each other. Okay, any questions, comments, or concerns with these? I know we talked about them yesterday, it's just nice to read those. Okay, now the other thing we talked about was how you name polyhedrons or by their bases. So like the idea is that if I called a triangular prism, the triangle's the base. Like the 2 parallel walls are triangles. So this is the idea. So on this one, these are the bases, and then we have then you have the rectangles connecting them. That's kind of how these work. Then you have rectangular prisms where the bottoms are rectangles. In fact, I can't even tell in this picture which ones are the bases because they're all rectangles, front, back, right, left, top, bottom. So, but it's a rectangular prism. Or I know like earlier we called it the cube, right? That's where they have squares. It's still a rectangular prism, but the cube, like the perfect squares, that one's a regular polyhedron. So that's why they call it a hexahedron. Then pentagonal prism, where the bottom and top are pentagons. This is the same picture I showed you earlier. All right, you can go any other sizes. Hexagonal prisms, dodecagonal prisms. So it just depends on what the bases are, and they're always connected by rectangles going on. Okay, now the pyramids. We have the triangular pyramid where the bottom's a triangle, as you can see here. We have the regular or rectangular pyramid, which is a square. That's what most people think of like when they think of pyramids. There's a few pyramids that are actually triangular in shape, but most of them are square because they hold better in the sand. And then pentagonal pyramids. Anytime you can change the base, then it's still a pyramid if it goes up to a singular point. So the bottom's a pentagon. Now, where you'd see this type of thing would be the only structure I can think of is like a Native American teepee would be like that, where the base can be any shape that they want it to be, and then they just have the the actual skins wrapped around and actually forms like a pyramid shape teepee. And the base can be anything. So that's the thing I can think of. Also pencils. Like when you first get a pencil, pencils come in that shape, right? That they have faces to them. I know some are rounded, but some actually have like really rigid faces, kind of like golf pencils would do that. All right. So now, let's talk about this pyramid of Giza. Okay? Pyramid of Giza was a square pyramid. So here's a picture of it. Right? I wanted to show you this from yesterday. That is a huge structure. Because I think we got cut off by the bell yesterday, correct? Mm-hmm. We didn't get to see this. I love this picture. If you have really good eyesight, if you don't, speak closer, but you can see the people here that are standing here. Like this is a person that's standing about halfway from the pyramid to the camera. Okay? There is a person right here, standing there. It's in red, with a red jacket on. Now, if you had a really good eyesight and you weren't on a projector, you can actually see this in pretty clear detail. Each brick that you're seeing here is about 3 to 5 feet tall, going up. It depends on how high they want to shorten them up a little bit near the top. But there's like 300-400 bricks stacked on top of each other, going to the top. Okay, so this gives you a sense of scale. This picture was taken early 90s, before 9/11 happened, because they allowed you originally you could just walk on, climb and go in it, that type of thing. But now since terrorist attacks and stuff, they basically just fence it off. You can see it from afar. But the doorway to it is actually right here. This is the doorway. You can climb in. It's about 30-40 feet up. Then you can go in. That's where the doorway is. Then it goes like a really steep slope downwards when it first enters. I'll show you a picture of that here in a second. But this gives you a sense of scale, like how big this thing is. Like it's huge. Just recently, I think it was within the past year, a 16-year-old kid actually climbed it. Scaled the fence, climbed the thing. It took him 6 hours to get to the top of it, and he was a young kid. He was 16. He climbed it all the way to the top. He had his GoPro. Took a bunch of pictures from the top. Got arrested immediately when he finally climbed down later that night, and got thrown in the Egyptian prison, which I would never want to be thrown in. He was very lucky that they let him go. They saw that it was a very innocent thing. They saw his pictures. They actually liked his pictures because it took a picture of Cairo and everything. It looked really beautiful, but they allowed him to keep it. He's lucky. He didn't get flogged for doing something like that. You don't know what flogging is. It's whipping with like 6 talons on the end of the whip. I mean, that could have killed him. He could have received 20 flogs for that. If you want to see that, he has it posted to YouTube. You can actually watch his full scale to the top. You can see he sat up there for like an hour or two to catch his breath because he was so out of shape from climbing that. When he's on the top, it looks like it's straight down. It's the scariest view ever. You don't get a sense for how this works. This picture kind of is like bottom up. Like you really can't sense like how like steep this thing is. Like, it's just almost vertical, straight up and down. Because I mean, there's not much gaps between the bricks. I mean, there's only maybe a foot gap between the other bricks, so it's really steep. But this is kind of what it looks like from better lighting. You can kind of still see the top. It's covered in limestone still. The whole thing used to be white limestone, like perfect white limestone. So when the sun hits it, it was actually blinding to look at it. It actually could burn your retina by looking straight at it during a bright sunny day. The pharaoh didn't want anyone to stare at his burial chamber, so like it could have been white limestone. But over the years of sandstorms, it was just deteriorated. Now, if you don't know what a sandstorm is, this is a sandstorm. Okay, it's a hurricane force winds that basically sandblast everything. This is from the U.S. military base in Cairo. Okay, they travel like 600 miles an hour. So, like, you can see it on the horizon, and it's on you within 20 minutes. And if you're out in it, it can literally kill you because it will sandblast your skin off. So, I know we have sandstorms in, like, Arizona, and we do have sandstorms in the U.S., but not to this, like deadly power that these come on, because they basically travel across the Sahara, which has no structure slowing it down, and it picks up speed as it goes. So it just when it hits, they have like like we have tornado warnings, right? They have sandstorm warnings that it's coming in. You have to seek shelter immediately, like immediately. You won't have time to like lollygag around. Usually what most people do is they get like in a car or they'll get in like a building itself. But I mean, you can't stand outside in it. You will not survive that. It's just silly. And it's tall. I mean, these are 500 feet tall. That's why when you look at the picture, why it's deteriorated. That is a huge building. It's taller than a skyscraper. Just to wrap your head around this. Okay. I'll show you a picture of what it actually looks like. But before there is 3 of the pyramids. The pyramid of Giza is actually 3 different pyramids. They're pointing perfectly north. I love this picture. It's actually facing north. You can see the sunrise coming up. So it's like you can see where the east is and the north. But they face perfectly north, like they're squared to north for being like built. The geometric north, and they're parallel to each other. They're actually squared to each other, and they're actually offset. So you can see the pyramid of Khufu is biggest, and then it's Queen's burial chamber, and then I believe it's a serpent that is like the high pyramids there. But the actual pyramid itself, actually, there's 3 of them, and this is how they look. Okay, it's not a perfect line. It's not a perfect line. It's offset. So people are like, that's weird. Why do you build it offset? It doesn't show. Like to me, like if I were to see that, I was like, they're not like straight with each other. That was actually on purpose. The 3 pyramids you're seeing are actually matched perfectly with Orion's belt in the sky. So Orion's belt is the winter constellation for us if you're into astronomy. It's usually in the southwest corner of our sky. It's just the 3 bright stars, and they make a little belt, and then there's other constellations that come off of it, and it makes a picture of Orion itself. But the belt is the most iconic image of it. But the 3 pyramids are actually built with those stars. Okay? And I haven't even touched the surface of how crazy the engineering was to make this work, because they're actually they're in accordance to which one's the brightest star. So the star's the brightest, and then this other star that's bright, and then the other pyramid is smaller because that star in the sky is actually different. So, and I haven't even touched the weirdest part of this yet, and you'll see this in the next slide of how crazy engineering this was to match the stars. Because I'll show you one more slide, and it's hard to believe. All right, this is how big the structure is. Okay, that is the Statue of Liberty, which is huge, bigger than most skyscrapers. Right? This is a skyscraper. This is a skyscraper in like general size, right? Couple stories. This is a person. Actually, a little bit too big, but that's like a really tall person. The thing from Rio de Janeiro, right? Then this structure is the thing that they built for the London Olympics back in 2012. It's actually a slide, a tube slide. I think they call it like the astro-orbital slide or something like that in London. It's right next to the London Olympic thing. But then here's the Eiffel Tower, which is just huge. I can't remember that. I've never seen this before. But this is huge. It's really big. It definitely dwarfs most skyscrapers for us. Most skyscrapers. They've only come to about here. Right? So, I mean, it's just big. But here's the inner side. So I told you where the doorway was, right? That 40 feet up. You go, basically down a really steep ramp, and then if you keep traveling down, you go to the lower chambers where the servants were. If you go up, you'll get to the main gallery chamber where all the prized possessions were held. Below that was the Queen's burial chamber. And up is the actual King's burial chamber here, the antechamber, whatever you want to call it. The crazy part about this is where prized possessions would be held. So during grave robbing, this would be the first thing to hit, right? But the King's burial chamber, if you see these little striations going off the picture, those are air vents. Air vents are I think they said they're 4 by 2 or something like that. They're really skinny, and they're laser cut. mean, it is just a perfect shaft. There's no breaks, there's no weird things in the middle of it. And it's a perfect laser. And what they figured out is and this was on the Discovery Channel, they put an RC car into one of them, something that could actually fit in that gap and drive up the ramp, like where that air vent was, and they strapped a GoPro to it. And when they drove up the ramp, it actually pointed to the Orion star that it was directed to. Like, it's the only thing in that view when that RC car was looking up was Orion Belt star that it's matched up with. I can't even wrap my head around that level of engineering. Because this wasn't made after the fact. This wasn't like drilled out. It was made as they're placing the bricks so that it worked perfect. I can't even think about the level of engineering 10,000 years ago when this thing was built. That they can make that perfect. Okay? I'm going to show you what this looks like. This part right here, this ramp, going up to this main chamber where the gallery chamber is. Okay? Here's the ramp going up. It's a 12-foot vaulted ceiling. This part right here is 12 feet high. Right in that little chamber going up. Okay? Now, it doesn't look great, okay, because it's obviously built of sand and limestone, right? These bricks are in perfect alignment with each other. I mean, they're smooth to the touch. You cannot fit a credit card in the little gap where the bricks are. That's how tight they are together. Now it looks like it's rigid. It's not. It's actually smooth. It's just, there's sand and they're breaking down a little bit. But I mean, it's steep. They actually had to add a staircase in there so you wouldn't fall over walking it. But this, I mean, originally you could walk in, which I think is just awesome to see that. But I mean, look at that. That was not built after the fact as well. That was built as they're placing bricks, spiraling up, building it, and then spiraling back down. The bricks were put in place so that this was in the middle of it as it was being built. It wasn't built after the fact, like what we normally do. Where we built the structure and then you work the inside and make everything look pretty like they're doing right now. This was built as they built it. So I just love that. I love that idea. But look at that. I mean, that to me is crazy. And all three pyramids, have that same kind of structure on the inside. Okay? I know the most recent thing that Egypt has been doing recently is they've been using infrared technology, like taking CAT scans and scans of the inside of these pyramids and stuff, and they did it for the Valley of the Kings, where King Tutankhamun's burial chamber was found, because they abandoned like pyramids because they kept getting grave robbed. So they went to the Valley of the Kings where they could hide in like a cliffside, and the idea was when they did scans of the big pyramid of Khufu here, they actually found there's one weird area in the weird corner, like right here. There's an area in the corner that is showing a different temperature reading than the rest of the bricks around it. That means it's like a doorway. It's a gate. It could have been the last of the bricks that were placed there. And so possibly that there could be a second entrance going in a different burial chamber in there. But so they're still doing scans. I don't think that they'll ever like remove bricks to look inside of it because they don't want to break the structure itself. But that's kind of the most recent thing. I know in the Valley of the Kings and King Tutankhamun's burial chamber, they found a wall that was a fake wall. So that was the most recent thing. By doing those scans, they saw like when they looked at like the scan of the room, they just put infrared and they panned the camera over. There was one just on the wall itself where they have a bunch of hieroglyphics. One wall had a perfect outline in a different color of where a doorway is. So they know there's something behind it. And that's where they think Queen Nefertiti is actually buried, which is probably the most iconic queen in all of Egypt. Right? She was considered to be the most beautiful other than like Helen of Troy and stuff. But that's why they thought King Tutankhamun's burial chamber had too much gold when they first found it. Like it had way too much gold for that pharaoh, because he was only a pharaoh for like 8 years or something like that. I think when he died, he was only like 15 or something like that. And they thought it was kind of weird that he had so much gold for being so young. Well, now they think that his queen was actually buried with him. Because she passed, and then they put all the gold in there after the fact, and she took over when he died. So they think that she's actually buried behind, which would actually be probably the biggest archaeological like find ever. Like because if they actually get past that wall, which they're thinking about like removing it and stuff to actually get behind it, it could produce even more wealth than you'd ever imagined behind it, because there could be more rooms behind that wall. Because I think the gold that they found in King Tutankhamun, I think it was over a couple $100 million worth of gold, which like in those days is like trillions of dollars worth. So I mean, it's just the level of money that they had was just unimaginable. But again, I can't wrap my head around this. Like the engineering that was involved like 10,000 years ago, it's just crazy. Now, what I want to finish with today, this is my last slide, because I know we have like a minute here. I want to talk about surface area, which is two-dimensional, right? And I want to find volume. So tomorrow what we're going to do is we're going to look at these structures. I'll put a couple pictures on the board, and we're going to look at how do we calculate area and volume. So what we'll do is maybe I'll put a cube up there, a prism, or I'll put a pyramid, and we'll just go through these formulas to see how it works. Does that make sense? Okay, so that's kind of our goal tomorrow. A little bit of history lesson for you in math. Really, can you get the light for me on your way out? Thanks.
Cowboy is dead.
Morning.
Morning. Your mustard today, who's your ketchup?
Title Country. Oh, we found these at Goodwill.
Oh, that's a good find.
It
That
was.
is a good find.
It was a good time.
Morning.
That mustard?
Yeah, it is mustard. Are you relish?
Huh?
Are you relish?
I'm gonna take the shirt off.
Where'd you get